Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day. And today's problem is Geeks Island, which is a medium level problem. So this particular problem states that we have been given n into m mattress and there are some seas. So Indian Ocean is on the top and the left edges and Arabian Sea is from the right and the bottom edges. So for example, this is the matrix form in the sample test case. So this might be the Indian Ocean and this might be the Arabian Sea, right? Now it says that due to the rainy season, it receives a lot of rainfall and the water can flow from the cells which have a higher value to the cells which have a lower or equivalent value. For example, from 5 it can go to 1, it can go to 3, it can go to 4, but it cannot go to 6. If there was 5 here, it can still go to 5 again, right? From 5 to 5 is possible, but from 5 to a greater number is not possible, right? So we need to find the number of cells from where water can flow to both the Indian Ocean and the Arabian Sea. Right? We have to find the number of cells from where the water can go to both here and here. So it is assumed that any of the cells which is directly connected to the sea, from there water can definitely flow. Right. For example, we have 6 here, so it is directly connected to both Indian Ocean and the Arabian Sea at the same time. So from here, the water can directly flow. So this will definitely be the answer. Similarly, this cell also will definitely be the answer in all the cases, right? And I'll give you some examples. They have concluded that the answer is 8 for this particular test case. I'll tell you how. So these two cells are directly connected, so no problem. From this particular cell 4, it is directly connected to this particular this Arabian Sea, and if it goes to the top cell, the cell above it, it is also 4. It is connected to the Indian Ocean, so this is also possible. And in every other cases, like you will observe that there is at least one way to go to either of the oceans, to both of the oceans. For example, 5 from 5 you can go to 3 and 1, and then you get connected to this. From 5 you can go to 4 and 2, and then you get connected to this, right? Similarly, you will have to do for all those things, right? So now I'm going to explain you the solution to this problem, and the solution code will also be available in the description. You can check it out after this video completes. So I've solved this problem with graph and DP. Although the form of DP I've used, from my knowledge, I would say it is not any standard DP. It's just what we have learned from DP, we have utilized here, right? So let me just show you the graph first. So if this is the mattress, we know which edges are connected because there is a condition on how we can travel, right? We can only travel if for example, if the destination is this, if the value of the destination is less than or equal to the value of the source. We can only travel directly between two nodes if this condition is satisfied. So how can we travel? We can only travel in up, down, left or right movements. We cannot travel diagonally. So we can only use these movements into adjacent cells only if this condition is satisfied, right? So this forms a kind of a graph. You will see that some edges are connected, some edges are not connected, right? So once you have formed the graph, you can easily determine from which cell, from cell A, whether you can reach cell B or not, right? So for example, if you are somewhere here, you can determine whether you can reach some cell of this thing and some cell of this thing, right? Because if you reach here and here, you will reach the Arabian Sea, and if you reach here and here, you will reach the Indian Ocean, right? So you can choose to go to either of these and either of these. For example, let us name it X, Y, P, Q. So you can go to either P or Q, and at the same time you have to go to either X or Y, right? So this is our condition for any cell to visit both of the oceans, to get to both of the oceans, right? For the water to get to both of the oceans. But the problem is we cannot check this thing for each of the cells individually, right? So this will be a lot of problem, because like even if you do DFS, it will take a lot of time to do this for all of the cells, right? So what we can essentially do is, if I know that I can reach from this cell to this cell, and I already know the answer for this particular cell, then I can utilize this answer because the answer will be same for this cell as well, right? Because for example, if I have a cell here, I know I can reach to this cell, and I already know the answer for this cell, then the answer will be the same or even better for this cell, right? So let me just explain it in a better way. So all of the cells which this cell can reach will be a subset of all of the cells this cell can reach, because from this cell you can go here. So from here, from here, let us assume that you can go to P, Q and R positions. Then this cell should also go to P, Q and R. In addition, there might be some other positions which you can reach from here also, ST, right? So this thing is a subset of all the positions you can reach from this cell, because from this cell, from this particular cell, now you can reach P, Q, R, S and T, right? Because this cell might be connected to some other cells as well, right? So we can always use this information to calculate where we can reach from this particular cell, right? So how can I use my DP here? I have defined my DP states like DP of ij will store the information for the ith and the jth cell I comma j. From here, which are the oceans we can reach. So I've used some bits. For example, I've assigned 2 bits. If I can reach the for example, let's say Indian Ocean, the 0th bit will be 1. If I can reach the Arabian Ocean, Arabian Sea, then this bit will be 1, right? So let me just go you through some examples. If you can reach none of the oceans, the answer for DP of ij will be 0. If you can reach only Indian Ocean, DP of ij will be 1. If you can reach only Arabian Sea, DP of ij will be 2. If you can reach both of them, DP of ij will be 3. So I've used some bits here to like just simplify the way we write this, right? So for any cell, for example, if you can reach from let's say I comma j to P comma Q, from this cell you can reach here. So dp of ij will be equals to dp of ij, or, and this is bitwise or dp of pq. I hope you guys were able to understand this thing, what I'm trying to say. So for example, if you can if from ij you can reach let's say this was the Indian Ocean, right? This was the Arabian Sea, right? If from ij you can reach the Indian Ocean, then dp of ij would have been 1 initially, right? Let's just read it. So this would have been 1 initially. If you can reach the Arabian Sea from pq, this would have been 2 initially, right? And you can reach PQ from ij, so dp of ij should be the OR of these two things, and it should be 3, because now from ij we can reach both of them, right? So this is the analogy, that this is the like understanding that we are using. For any cell, we know where we can visit, which are all the cells we can directly visit, and for those cells, if we have already computed the answer, we don't need to compute it again. So this is the form of dp that we are using, right? And to find out which are all the cells we can visit from a particular cell, like the adjacent ones, you can use just a simple graph knowledge. You must have done it in like, this is called grid matrix, and it is easy to traverse through this grid, right, in the form of a graph. So this will be the logic. Let me just go through it again once more. So we have been given some things that we can only move in up, down, left and right directions. The second, this is the first important condition. The second important condition for the movement is that the value of the destination should always be less than or equal to the value of the source, right? If you're talking about two adjacent cells, right? And this will always be true in the longer run. If you are talking, for example, if you are at 5 here, this should be at least 5. This should be at max 5, or it can be 4 also, and this can be at also 4. This can be 2. So you will always find that the destination is always less than or equal to the source, right? So this is the second condition. Now how do we remember the answers? Because to find out for each cells individually, it will take so much time, right? So what we rather do is we remember the answers for each cell. For example, if I can reach from cell A to cell B and I already know the answer for cell B, then I'll reuse it for cell A. Now this question is, how do we reuse it? I've explained it here that if from cell B, if you can reach P, Q and R, and if from cell A you initially were able to reach S and T, now from cell A, when you know that they are connected, you will be able to reach P, Q, R, S and T. You will be able to reach all of them, right? So this is what we exactly do. dp of ij would be equal to dp of ij or dp of pq. Pq is the destination, right? So we are going to do the bitwise OR of both of them. Why only bitwise OR? Because we are using this bitwise OR because I've decided to store it in a format such that bitwise OR is applicable, right? I've used this particular format to store my information. I've used some bits. I've used 2 bits to determine which C can be reached from the I and the jth cell, I comma jth cell. So for example, 0 denotes we can reach none of the C's, 1 denotes we can reach the Indian Ocean, 2 denotes we can reach the Arabian Sea, and 3 denotes that we can reach both of them. So that is why we are going to use bitwise OR. Now let me just show you the code now. So for example, this is the starting of the code, and I just use some variables n comma m. I've maintained them as global variables. This is for just my ease. You can do this is not a necessary step to do. Right now, I've created 2 vectors. This is like 2-dimensional vectors. dpn visited will denote whether the current node has been visited or not. So I am just using a for loop for all the nodes or the cells in the matrix. If it is not visited, I'll call the DFS function to visit that particular cell. Right, now let us just go to the DFS part. First of all, I just do simply that visited of xy is equals to 1. Now, if I see that I am on the left or the top edge, x is equals to 0 denotes this particular row, right? Because it is on the top, it is directly connected to the Indian Ocean. So I can OR the result of dp of xy with 1, right? Because I know that this is the topmost part and it is directly connected to the Indian Ocean. Similarly, when y is equals to 0, so this is this vertical row with vertical column where it is also connected directly to the Indian Ocean, right? So I am ORing it with 1. Similarly, for x is equals to n minus 1 or y is equals to m minus 1, x is equals to n minus 1 will be this particular row, right? And y is equals to m minus 1 will be this particular column, the last column. So it is all connected to the Arabian Sea. So I'm ORing the dp of xy with 2, right? Now the next thing which I need to do is I'm using a for loop. So I'm just trying to find which are all the adjacent rows. So if you have done this grid traversal, you must be familiar with this method where we just declare 2 arrays dx and dy, and we just store the positions, like the change in positions. For example, if you want to go up, the x variable has to be reduced by 1 and the y variable does not change. Similarly, if you have to go down, the x variable has to be increased by 1 and the y variable does not change. And like similarly, the list goes on. So I've also commented this for easier, so that it is easier to read, because such that like this particular thing will make you move upwards, this particular thing will make you move downwards, similarly left and right, so that it is just easier to read. So what I do is I just run a for loop from 0 to 4 because there are 4 possible positions, and I just do xx is the new position I want to reach and yy is the new position I want to reach. So xx will be equal to x plus dx of I, and yy will be equal to y plus dy of I. So this is just basic DFS stuff. Now I just check whether the new position is valid or not. So for it to be valid, obviously it should not lie outside the cell. So this condition is for that. So I'm returning false. This condition is just to check whether the new position has the value greater than the current position. Then also we cannot go to it. Otherwise we can definitely go to it. So it is valid. So it is a valid position, right? Now if the position is not visited, I just again call DFS on it. Oh sorry, this is the wrong part. So if the position is not visited, I again call DFS to it, right? So in this part, I'm again calling the DFS function, and when I return from the DFS function, I just OR it like I've shown you earlier. So dp of xy or is equals to dp of xx by y. So this is just shorthand notation to OR the result. And when all of the DFS is completed, what I do is I just initialize my answer with 0. I just run a simple for loop for all the cells, and for all the positions where dp of ij is equals to 3, I add 1 to my result or my answer. So like this might confuse someone. So this is a condition, right? So this is a condition. Whenever it is false, it will return 0. Whenever it is true, it will return 1. So if it is false, 0 will get added to the answer. If it is true, 1 will get added to the answer. So this is a neat trick to do this. And at the end, I just return my answer. So this was the solution for today's problem of the day, Geeks Island. I hope you guys were able to understand the solution. And if you guys did, subscribe to this channel. And I'll also be leaving the link to the code for this particular question in the description. You can check it out also. So till the next video drops, keep coding, stay safe. Bye bye.